Good evening and welcome to our webinar. I'm Chris McLaughlin, Secretary, IET Ireland Network. So without further ado, I'll pass to the Chair of the Ireland Network, Ching Man Ching.
Thank you, Chris. Good evening, ladies and gentlemen. I'm Ching Man, Chairperson of the IET Ireland Network. I'd like to welcome you all to this evening's webinar. Our speaker for this evening is Ken Nichols. Ken has over 30 years of engineering experience. 10 of those were in developing and testing automated telemetry systems and over 20 years in renewable energy and sustainable living. I will now pass it to Ken to make his presentation. Ken, when you're ready, thanks.
Good evening, everybody. My name is Ken Nichols. Thanks for the introduction, Ching. I will share my screen here for the presentation. Just a little additional introduction. I think Ching introduced me quite well. Yes, I have about 35 years in software and hardware engineering experience, 10 years in the utility industry, actually developing automated systems, telemetry systems for water, electric, and gas. So I'm very familiar with the utility industry and the data collection especially. 20 years, yes, in renewable energies, mostly PV and sustainable living. Done a lot of trekking throughout my life since my childhood. So I'm very passionate about the synergy of technology and nature. My own home resident is off-grid. I've been completely off-grid for about 1.5 years, including powering an electric vehicle. So to set the stage for tonight, really, it is about the residential sector, steps that you can take to make the most out of PV systems. And it really is, it's not just technology. There is the technology aspect, but it's your home systems, how you operate your home, the systems you have in your home that can work in synergy with PV, and also human behavior. We've become very wasteful over the years of how we use power, when we use power, leave things on in standby, such forth, and how we can change behavior to also be in synergy with the PV power source. A lot of misconceptions really are to do with what can be done, which leads into I don't really know what I want because I don't know what I can actually do. Many people are just looking to lower their electrical bill, just basic electrical needs, also power failure from the grid. Can I operate? Do I need batteries? Many people are, if not all, at least that I'm aware of now, are installing battery systems to be able to have power when and if the grid fails. There's a lot of technology also for capturing excess energy that would otherwise go back to the grid into heating water. So domestic hot water use, it's quite a significant amount of energy that's used, and also central heating. Can central heating be done, and how do you do that? So let's get into it. This is a very big topic. We have a short amount of time, so I just want to dive right in here. Really, anybody that's looking to do PV on their home property or already have it, maximize it. Put as much up as you can, and you need to be creative about this also. So it gives you more potential for generation capabilities. And then on the other side, reduce the consumption and inefficiencies. Now, this can be done with behavior changes, the system changes in your home, insulation of the home, insulation of water tanks, etc. There's many ways to reduce this, say, excessive consumption. And then knowledge. This is a very big factor. Improve your knowledge of what power is. Where does a home use power? How does it use power? What appliances use power? How do you use your home? Many people, not everybody works in the same way, operates their home in the same way. So, and also if you're going to be capturing energy from solar, understand how the sun works. So we're going to dive into this here. Energy use in a home. Let's just take a look at some statistics. This is from Eurostat from 2017. Space heating, it's about 64+%. That's a massive amount of energy for one area, which is space heating. Water heating also quite high for domestic showers, sinks, etc. And then lighting and appliances. Mostly this number really is things such as refrigerators, maybe if you have a freezer, because this is a device that is running 24 hours a day, 7 days a week, and it consumes over a long period of time quite a bit of energy. But as you can see here, about 80% of the energy we use in our homes, and this is mostly looking at, across Europe, where we have radiant floor heating, we have radiators on the walls, which is water, hot water that is needs to be heated. So 80% of the energy consumed in the home is in heating of water. So let's be thinking about that as I go through the slides here. As I briefly mentioned already, it is more than technology. Obviously, the technologies such as PV panels, the charge controllers, the inverters, and all the cabling, and then your electrical storage in the form of batteries, that's all obviously the technology aspect that can generate, harness, and bring power in. But how do we, what about the systems in your home? How are they used? Do they integrate well with these technologies? If you are looking at doing larger systems and driving to be off-grid, for example, you obviously do want to contribute a lot to central heating. So you do need to have a thermally sound home. A lot of new homes today, obviously in many countries, are being built into very high standards from a thermal standpoint. Also, as water, we've just discussed, a thermal battery is storing a lot of energy in water. How do we integrate those? And then the human aspect, energy management, awareness and education. If you are going to put a power plant on your house, if that's a 3 kilowatt system or a 30 kilowatt system, you're going to need to be monitoring this. You're going to be doing some management. You wouldn't drive a car across country without any functioning gauges. And as such, you need to be looking at telemetry from your system in order to make decisions. How much energy am I using? How much am I consuming? How much am I generating? What's the state of charge of my battery, etc. And in order to be able to understand this, you have to have an understanding of power usage and consumption, what happens in the home. But also is really paramount is understanding the weather and the patterns in the solar activity. Where does the sun rise and set? How high does it get in the sky? What effect does that have on power generation? These are really critical things, especially, as I said, if you're driving to be very independent, and the geographic region you're in. It can be quite challenging to generate power in December, January in the very parts of the northern hemisphere. And then the behavior changes, obviously. How can you change your behavior to reduce your consumption, to reduce your inefficiencies, and take advantage of when the sun is shining? You can also make energy when the sun isn't shining on even cloudy days, if you have enough generation capabilities in the time of the year, but you need to adapt. So I'm going to take an example here to how maximize PV. How can you design a system that can be scalable, even from a small property? So this is someone I have worked with and is wanting to get into PV. It is a small residence. It's a semi-detached house. No garage, quite small property. And their initial quote from several PV installers was for about a 3.8 kilowatt system on the roof with a 3.6 kVA inverter. Now, you're not going to be able to do a lot with that, really. But as I've spent time with the folks, there's a potential on this property for over 10,000 watts. And with 10,000 watts in Southern Ireland here, you do have the potential to be self-powered or independent for many months of the year. There is high potential on this property, but this is the kind of initial target for 10.2 kilowatts. And as you can see on the picture, the roof actually can support 6.4 kilowatts, including meeting all the guidelines and regulations in Ireland here. Even for the grants that are available, you can put a 6.4 kilowatt system up on the roof. They have a small patio, which is going to be rebuilt. And so the roof for this, this is not an enclosed patio, this is open. You can put 1.7 kilowatts of PV on there. Additionally, they have a very solid shed at the bottom of their garden, and it's 2.1 capable. South here is actually straight down on the page, so the rear roof of the property is facing about 170 degrees azimuth. So the shed would even be an east kind of west orientation, which can be beneficial at times of the year. So obviously, you know, for financial reasons, this is not all going to be done at once. They want to be able to do this incrementally. So a system needs to be designed in order to be scalable, to allow for easy expansion. And the target is to be high self-consumption. They want to use all the energy that they generate. And this is really the goal of any PV system. So you need to be creative, really. You know, nobody from all the PV installers they discussed came and visited the property. But you can obviously roof mount is the first place that many people think of. Ground mount is also possible. Wall mount. Working with the system right now has a very large solid concrete wall at the back of the property, and that's where the initial 11,500 watts of PV is going to be mounted. So this type of system, there's many system designs for PV systems. This is what's called a DC couple system, has multiple charge controllers. So each area here, the 3 different areas, will have a dedicated charge controller, which I'll show in the coming slides. And as I said, self-consumption, using as much power as you can. And really the goal here and on larger systems, especially that I work with, don't look at the grid for export. It's the grid is there if they need it to recharge the batteries in the wintertime. If you can put in enough PV, you can, and you manage power well, you can be self-powered. And then you use the grid as a generator to top you up, let's say, if your battery gets low in December, January, for example. So initially, this property is going to have 6.4 kilowatts mounted on the roof into one charge controller, which feeds into a 5 to 7 kilowatt hour battery and a 5 kVA inverter. That's the initial investment for this family. As they build out, we can rebuild the porch. The roof can be integrated roof system, PV system, and into a smaller charge controller, which just integrates straight into the system very seamlessly. This is DC couple system because where everything connects is on the DC side. So it easily integrates. And this isn't very costly to do. The charge controller is just a few €100 as on the panels. The next stage would be to increase the battery capacity. Now you have about 8.1 kilowatt hours of PV, which, especially in the summertime, even this time of year, you can generate quite a bit of power. So let's start storing some more. And obviously, as we can afford it, we have a battery system that is modular. We can expand. And 10 to 14 kilowatt hours is quite a good target to start being very self-sufficient for many months of the year. The next incremental step would be to double the capacity of the inverter. This gives you more potential in the home to start doing things in parallel, such as cooking and laundry and maybe dishwasher. And now you have 10 kVA, which if you wanted to have even an electric car, you can actually charge from the AC port on full capacity. And finally, adding the system to the shed roof with another probably around 3 kilowatt charge controller, which brings the total to 10.2. As mentioned, if they do wish to expand their patio on the back side of their property, you could even get up to about 12 kilowatts here. And you can do a lot with that. So that's a really good example. This is a typical scenario of somebody who initially was told to have a quite small system to being able to actually be very self-sufficient. So now we've looked at talking about generating as much PV power as possible. Now, what can we do in our homes to improve or be in synergy with this power generation? Obviously, if you're looking at doing some central heating and you're driving to be, like I mentioned, off-grid, having a thermally sound house. I think that's quite obvious these days. You need to, the less energy escapes, the less energy you have to put in. But let's talk about storage. You know, I think a lot of people think electrical storage with PV, batteries. I know systems that are going off grid are quite large, are putting very large batteries in. They're running because the design of their central heating is for heat pumps, which use a tremendous amount of electricity. And they can struggle a lot to recharge those batteries during the next day or the next days. So you don't really want to put all your eggs in one basket in all electrical form. As I mentioned earlier, 80% of the energy consumed in the house, especially across Europe, is in heating of water. So why don't we store large quantities of water and heat it? That's what a thermal store is, which is the top picture here. This becomes a thermal battery. And these devices also can take input from many other sources. And what is coming has been done already, but it is now starting to be more well known is hydrogen. Converting electrical power from PV into splitting water into hydrogen, and hydrogen boilers. Worcester Bosch, Worcester in this installation here is a zero carbon hydrogen ready boiler that can also integrate in with the thermal store. So it's really about diversification and storing your energy in many forms as possible. And just to talk about thermal stores going forward, obviously they can take sources from solar collectors, obviously PV, which has actually got a lot less, let's say, plumbing with it, straight into immersion controllers, immersion elements for heating the water directly, boilers, which also could be going forward, hydrogen, and the wood stove here. Obviously, I don't think you would use a wood stove like this. There are some very special types of wood stoves designed to work with thermal stores that heat the water directly, have a lot of safety features built in. And then the output from these can run underfloor heating, radiator systems. I have one of these in my home. It's 1,500 liters, and it is our central heating. So it works very, very well. And it's very easy to do. It's a lot cheaper than doing batteries. And due to the multiple sources, you need the space to put the large tanks, but people are maximizing out their tanks and increasing sizes to be able to store energy thermally. So energy and management, if we talk about this for a moment, the typical model for a PV system is, during the day when you're generating PV power, you're charging batteries, you export to the grid, you have some direct consumption, and then the energy you store in the batteries is used overnight. The problem with this is it's very poor self-consumption. You are exporting power to the grid, and usually the percentage is kind of reversed from what is shown in this diagram, as I'll show in the next slide. It is very high battery consumption on non-PV hours because you're operating in the wintertime, especially when you've got very short days. You are doing things in the evening that consume a lot of power, especially if you have systems such as heat pumps. And often you need the grid in the morning. Your battery is very depleted unless you have very large capacities. So people put larger batteries in, which lead to very expensive systems. So let's look at actually some real data here. The top chart is a system. This is from April of last year. This is in Spain, sunny Spain. The blue part of the curve here is actually the power generation. And if you look at that, it is a beautiful cosine wave, not a cloud in the sky on the 3 days shown here. Below the horizontal line, the green portion shows charging the batteries, and the orange is the export to the grid. So a lot of the energy is exported to the grid. The yellow curve shows the consumption within the home. And as you can see, the yellow does not eat into much of that blue curve. So it's very low on self-consumption when you have PV power. And that consumption rises after sunset. And as in the previous diagram, grid is needed in the morning. Obviously, people who are thinking of looking at exporting what you get charged for, what you pay for a kilowatt hour is not equal to what you are paid for exporting per kilowatt hour. So, like I said, you really want to target using this energy as much as possible. Now, the bottom chart, it is an off-grid system, and the orange chart shows the generation. The inner blue, light blue is the consumption. It's not as crystal clear of a day. You do see a lot of dropouts, especially as the day progresses, as clouds were coming and going. The difference between the orange and the blue in the morning is charging batteries. But this is the system that is using a tremendous amount, if not all, of the produced power. And then during the evening or the sunset to sunrise time is very low consumption. So the battery doesn't go down as much. You don't have to replenish much the next day. So rather than just charging batteries, you can do other things, many things in parallel. So let's talk about the changing habits. Now, we've talked about how you can generate the power, maximize the generation of power, and how you can apply that power with different systems in your home, such as heating water, lots of water. Now, how about changing the habits? I mean, really, the home systems need to be in synergy, as I mentioned, with the power source. We're used to operating on a system with a grid that is always there, 24 hours a day. If you want to go down and cook something in the oven at 3 o'clock in the morning, you can do that. You can do that on a battery system. You're just going to have to replenish that energy during the next day. Or if you want to do a lot of other things post-sunset with high appliances that use a lot of electrical power, you're going to have to replenish that the next day. So it's really about having systems that can capture a lot of the energy of the sun when it's available, which can be in the summertime about 2/3 of the day, but in the winter about 1/3 of the day. So it's about also changing habits to be in synergy with your power source that is only available for a portion of the day. So doing laundry, doing cooking, obviously heating water, but a lot of the things that could be either placed on timer if you're not at home, or if somebody is at home, can be done during the daylight hours. Obviously, if you're going to be cooking in the evening time and you just have electrical devices, appliances such as an electric hob or electric oven that you need to cook in the winter time when the sun has gone down, that's okay. But there are a lot of things that you can shift. And it's really also about minimizing the use of your battery, as I mentioned quite a bit. And there's a lot of parasitic consumption we have in our homes. A lot of things that we just leave plugged in and they're in standby. And this does add up. There are also devices that are drawing power that you may not be aware of. I've come to realize this over the last 2 or 3 years operating my own home. Devices that they're not on, but they're plugged in and they are actually using some power. This does all add up and can make a significant difference of what the percentage of your battery is in the morning. So the less energy you need to you lose overnight, the less you have to recharge. And I want to talk about these days in the winter because you have to understand also it's not just that the days are shorter, the sun is lower in the sky. If it's lower in the sky, there's less radiance. And also as panels are mounted on roofs, which are typically pointing up at the summer sky, there's a larger angle from that sun to the panel. Panels, as you can see on the previous slide here, with the nice blue cosine wave, it is a function, power generation from a PV is roughly a function of cosine of the angle of the panel to the sun. For example, if you're 60 degrees away from the sun is shining at like a 60-degree angle on the panel, cosine 60 is 0.5. So they're capable of only generating about 50% power. So if you imagine That coupled with less radiance because the sun is shining at a very low angle in the winter, it's got a lot more atmosphere to go through and the days are shorter. It can be very challenging to make power. So be aware of this when you are thinking about on where you want to install PV panels. But this does drive towards a lot of telemetry that you can use to help you conserve power. And this becomes addictive. It really does. Once you have the information in front of you and you can see where you're using power, how you're using power in the home, and it kind of becomes addictive to even install more PV. And you can find very challenging ways to add more to a system. So this is really something to very much look into. Okay? But this is probably not for everybody. To be able to change habits to take advantage of when the sun is shining. I've had people tell me, I just want to be able to do whatever I want, whenever I want. But you won't be able to take the PV systems to the full potential. So I want to summarize some things here I've talked about. Maximizing the PV. Like I said, look at ways to and places that you can install it in your property. This drives capabilities to have larger battery systems because you'll be able to charge them. Larger inverters, which means you can do more things at home, in the home, and do more things in parallel. And this leads to a lot greater potential and then less dependence on the grid. And this is really where you want to go. I think many people think that you have a PV system, you install it, you connect to the grid, you have a relationship, a contract with your power company, and you export excess. But there's, depending on countries, I've lived actually in 4 countries, I do know, and design systems in some other countries besides Ireland, that the regulations can be quite strict in some places and very restrictive, that you can't have such a large system. You can't do this if you want to have that relationship with the power company. And also, you need to understand those regulations and the guidelines. And sometimes the PV installers aren't electricians and they may not enable a proper architecture design and design such a system as this. So one component of what I call the 3 pillars is the education, to improve your education. Know the rules and regulations of where you live, what the capabilities are. Understand, as I mentioned already, solar activity, the weather, where does the sun rise, how will it shine on my panels, what is the weather like typically in my region in given years, and it can change from year to year. The data I have from the last 2 winters are quite different. Also, one other factor is understanding the PV system components and the features. If you're going to go buy a new car or a new printer or any new device, you need to understand the features. What is this capable of doing and what do I need? And you're going to be putting this on your property, your roofs, so you need to understand the systems anyway. Really, you are taking over, excuse me, some of that management. And when you pay for service from the grid, they are managing that power generation. You want to put something on your property, on your roof, you are taking on some of that responsibility. And you can do a lot with that, but you need to educate yourself on the systems and the use of energy in the home, how you use the home, and how you can reduce some of the consumption and maximize the potential for these types of systems. Obviously, I mentioned reducing the inefficiencies and modifying the behavior. This is probably one of the most challenging things for people, is to change habits. We all, well, many people have New Year's resolutions, and how long do they last? So, but when you have data that you can look at that's in your face, I have a large dashboard in my kitchen area, always looking at the data. So it does drive behavior change, especially when there's a financial benefit to this, where you can reduce your electrical costs. Also, even sourcing the PV components and the system components, whether that's panels or inverter, doing some of your homework to actually be able to get a good price on things. I worked recently with somebody who has put in quite a large system, or is in the process of it, but did a lot of his own legwork and was able to save a tremendous amount of money. Actually got a very, very good system, very large system, and is going to be able to do really, will be offered eventually. So that's something that definitely you need to be looking into. And then again, yeah, maximizing your potential for generation. Having a scalable system design, obviously finding somebody that is knowledgeable about the design of these systems and also working with you to help you achieve what you want rather than what they can sell. Find a lot of this in places actually, unfortunately, that are selling kind of packages and will try to convince you that you need what they're selling versus what you want to achieve. So education and knowledge to push back on this and say, no, this is what I would like. And then finding somebody who will work with you to help you achieve your goals. But finding somebody also who is knowledgeable enough about the design of the systems, that can be challenging. But do a little bit of your own, homework regarding your property, where you could potentially put panels. Very scalable systems can literally just have 2 panels that could integrate, as well as large, installations where you may have up to 30 panels that can be tied together. So I've seen quite a few installations where people have panels all over the place, but they have a very large system, which is quite effective. And you also want to strive towards self-consumption. Use as much as the energy. Do not look to, you want to push power back to the grid and you're going to lower your bill that way. That is not how you lower your electrical costs. It's by using it yourself and enabling yourself to have such a large enough system that you can do something with it. As I mentioned, the rules and regulations are very different across different countries, and some can be very, very restrictive. But still, if you're looking to try to use your power as much as possible and also use the grid as a generator, really. If you are able to get to 10,000 watts, you can do a lot with it in many, many places around the world. And being here in Ireland, which is not known for the sunny weather, we do get quite a bit of sun and we can generate quite a lot of power. I have the data to back that up with my system. So I think that summarizes it. I hopefully have tried to enlighten or open the eyes for many people of how to do things differently. Again, it isn't just technology. It isn't just getting PV systems. You must be involved with this, and to make the most out of it, you need to be in synergy with your power source and when it is around, and modify potential systems in your home to take advantage of this also. So that's the end of the presentation, and I guess now I'll be open to questions.
So Ken, Chris here, just as you're opening the Q&A box there to have a look, I just have questions myself. Has any talk or consideration been given to having solar panels that will automatically follow the sun? And if such work has been done, would the energy gain be justified against the additional cost of putting in such a system?
Yeah, that's actually a good question, because I actually 50% of the panels I have in my system is on a tracker that follows the sun. So it is an automatic system. It is a pretty big installation, yes. And really, as I mentioned, the angle of the panel to the sun is a drastic difference. If you see the cosine curve, it doesn't take too much either side before you can have a drastic fall off in power. So for me to be as efficient as possible, I did put that in. I did put a tracker, solar tracker in. It has 12,000 watts on it, and it follows the sun all through seasons. It is, so yeah, it does do the benefit of, less panels. There's kind of a double answer to this. Yes, you need less panels to produce the same power, but it's when is the sun coming out? I've had instances at certain times of the day in very bad weather where I thought, I'm not going to charge up today. And then late afternoon, the sun comes out for 15 minutes and I'm pointing right at it. And then I can really maximize the power and fully charge back up. sometimes you get sun for just 1 hour in the morning. And if you're pointing at it, you can grab that and charge your battery and do other things. Whereas, you know, if you're pointing south and the sun is, let's say, 90 degrees off to your side, you'll never capture that energy. So it's a bit of, there's quite a few variables in there. Does the cost outweigh it? You know, I do a lot of the work myself. I have a lot of contacts also in China for such systems, which can drastically reduce the cost. And there's not too many things I can't do. So hopefully this is answering the question. You know, tracking the sun does take some space. It is beneficial for you. You know, you're getting the most out of the panel. If there's an environmental cost to the manufacture of that panel, these panels, when they're tracking the sun, they're optimally grabbing every single what they can at all times, rather than waiting for the sun to pass by.
Thanks, Ken, that's fine. So at this stage, if you want to take questions from the Q&A box.
Okay, start from the top here. Yeah, Aidan Langley, is there a diminishing margin of return once you've got 3.8 kilowatts of panels? The cost of putting the next 3.8 kilowatts delivers a smaller return. I'm not sure what you mean by a smaller return here. I mean, the initial cost is, you know, this is such a design of the system that is scalable. You have to put more infrastructure in up front because you have an inverter, let's say. On a system that is scalable, such as a DC coupled system, you're just adding panels and charge controller. So the costs are much less. You are doubling the capacity of the system. And if you avail of that power, put it to use, you know, you have more potential. So hopefully, I don't think it'll be any diminishing returns. If anything, you're getting, if you use it, you're getting twice as much power for less investment to expand on the system. Hopefully that answers the question. See, from Alex, why do companies underestimate a house's solar potential? Are they reducing their own revenue? Well, actually, a lot of PV installers that I'm aware of, especially in Ireland and also in some other European countries, they have packages that they sell. They have relationships with manufacturers to sell certain types of, let's say, inverter. Typical installations would be a hybrid inverter, which can do, let's say, 6 kVA. And this requires, say, 385 watt panels and 10 of them. It's a package they sell. They can come in and they can do that installation very quickly and move on. So what I found, unfortunately, is that this is what they want to sell. This is the cookie cutter kind of approach. Everybody gets the same thing. It also comes down to rules and regulations. There are two schemes in Ireland here. One is microgeneration, which only allowed it up to 6 kVA. So this was the limiting factor that everybody got. You're just going to get a 6 kVA inverter and a certain amount of panels. And this is the model that everybody thinks they should have, is you buy a system, you install, you export to the grid, and off you go. Whereas, as in the example, this property has a potential to put in more, where they can be self-sufficient. But the design, the systems or the installers aren't actually, they're not really interested in that. It's more time and effort to design such a system and to show customers that, well, by the way, you could do more. And it's often been found now, the installers aren't even visiting homes, so they don't know. They might look at something on Google Maps, but they're not 100% accurate as far as up to date. And then they're ignoring things such as, oh, there's a shed at the bottom of the garden. They've got a patio here. Or, you know, you could put something on the side of the house. They're looking at speed of installation and ease of installation, really. It does take time to talk with people and say, well, what would you like to do? If they don't know, try to educate them, look at their property and say, look, you can actually do this and this. And then, oh, I didn't know I could do that. But it's more involvement, and that costs more. And oftentimes people are struggling to actually pay for some of the systems. So if you find somebody that can design systems properly, it can be more costly. They're looking for ease also. It's kind of a double-edged sword. The PV installers are looking for quick installations, and sometimes people want quick installations. Let's see, I'll just go down. There's a lot of questions in here. For the case, let's see. How long do panels typically last from Aidan Feehan? What rate does the target potential degrade? Panels have actually come a long way. I mean, typically they can last, the monocrystalline panels, which is predominantly what is sold now, you're looking at 30 years. They try to extrapolate, if you look at some data sheets, that are 25 years, they'll still be functioning at probably even 80%, some of them. Obviously, it's how you treat them. You need to clean them and look after them. My father-in-law had some cheaper panels. He's had them for about 16 years. They're still functioning well. So yeah, if you look after them, easily 20 to 30 years, you still be generating quite a bit of power. Does the voltage from PV panels vary greatly? If so, do you need a DC regulated charge batteries? And can a wind turbine be DC coupled into the system with different voltage rating than the PV panels? Okay, this is really what a charge controller does. Okay, so in a DC coupled system, you have a between the panels and the battery, which is also where the inverter connects to, you have a charge controller. It has two functions. It controls panel, because if you connecting, typically the way you install panels is in series, like connecting batteries together, they add up the voltage, and that charge controller can take up to a maximum certain voltage on the input, 450 volts, let's say. The output has to match your battery. So whatever battery manufacturer you have, whether that would be BYD or Pylon Tech, which is very popular, they state recommended maximum battery charging voltages. So it's no different than charging, let's say, a 12-volt car battery. You know, you put a slightly higher voltage in. Don't ever want to go above 15 volts, for example. They have a curve that they're recommending based on the number of cells that are inside the battery. They're usually 15 to 16 cells in series. And so you have to program that charge controller for these voltages. And that's how it's done. So if you're going to couple in a wind generator, which would typically have another charge controller, I did have one of these on my system, you have to program it to be the same. So in the case of the use case, the example I used, there's 3 different charge controllers. They were all programmed to be the same. Even on the inverter, which has charging mechanism built in, the values used from it. So if you're taking power from the grid to charge your batteries, the voltages have to be the same. So anything that plugs into the battery, it has to follow the manufacturer's recommended settings. Some of it is done automatically, as you have what we say CAN bus communications from the battery, which such as I have a Victron system. It's automatically set. They read the settings from the battery management system, and it's all set for you. So hopefully that answers the question. Mahesh Patel, using Victron equipment enables a scalable system design as per your example. A lot of solar companies fit hybrid inverters, Huawei Solars. Can we maximize scalability with these hybrid inverters? Yeah, exactly. The thing is with this is if you have a Solus or a Huawei, they're probably limited to 6 kVA on these hybrid inverters. If you want to, let's say, add another 6 kilowatts of PV onto the system, you're going to be doubling everything. You can put one on the system, a second one, such as, let's say, a Solus inverter, and then they're coupled on the AC side. So they communicate and they synchronize the AC output. So it can be done, but basically you're doubling your whole system. You have to have panels that integrate to a second inverter. Sometimes, depending on where you put panels, I've seen systems that had 3, 4 different manufacturers' inverters. And then it's how do you correlate all the telemetry. You have multiple dashboards because each company then has different dashboards, and you don't see the larger picture. So that's sometimes a problem. Also depends on the features within these, such as Solus or Solax, Solar Edge. Some of the features don't, let's say, enable you to do some of the self-consumption. I know here in Ireland sometimes installing some of these inverter Solus is very popular here. If the grid goes down, you can only use your battery system. It actually internally will switch off your PV, which is completely useless. I mean, you have a PV system, you can't use it. There are ways around this actually, but it depends on the rules, regulations. There are devices which are certified across all of Europe, but they're just not being used. They're not installed. Hopefully that answers the question. Bob, what is the feed to the DC-AC inverter? Does it have to come from a battery, or can it come directly from PV? Well, this comes down to the type of inverter that you have. There's not all inverters support battery systems. So those really are, my father-in-law's system, it's just a grid-tied inverter. The PV panels go directly into it, and it's actually a three-phase system that connects to the grid into the house, and it manages everything. But obviously, at the end of the day, there's nothing, it's off, the PV goes down. And also, if the grid goes down, you can't use the PV power. Typically, if you're using battery storage, you will have an inverter that supports the use of batteries. And many do, some don't. I think they're becoming far less common these days. Everybody wants to have battery systems. So. If you build, Aidan Feehan again, if you build a system designed to generate 10 kilowatts at install, at what rate does that decline? I think that's really like similar to the question earlier, is the degradation of the panels, maybe on the system too. And this is one thing to be aware of, is in a system that is grid connected, you're extracting as much power out of the system as you can. So maybe in the summertime, your system is running at maximum potential if you have a lot of sun. And that can put a lot of wear and tear on some of the equipment. Electronics, depending on where they're installed, they're going to degrade if they're running hot a lot of the time. Some of the cheaper Chinese inverters will not last too long under this. They run probably hotter than some equipment. And if you're running them to the max continually, it is going to degrade. Battery systems too, especially temperature, is going to have a really significant impact on the longevity of a battery. But as I mentioned with the panels, I answered that earlier, so hopefully it depends on the use. It's the same as anything. If you abuse something, it's not going to last as long. Or you can buy equipment that is designed to be running a tremendous amount of power for long periods of time. There's a lot of the Victron equipment, such as the Quattro series, they have been designed for that. A lot of people say they're designed like tanks. So they have a lot of marine installations, and you can't get a delivery of a broken inverter out in the middle of the ocean. So let's see other questions. Alex, my block of flats has solar thermal rather than solar electricity. Can you comment on the pros and cons of solar thermal? If that's the solar, I think you're talking about the solar collectors here. Yeah, they've been very popular. It was at one time, the cost of PV systems or at least PV panels was quite high. It's come down tremendously in the last 5 to 10 years, especially. So it's very cost effective to do electrical PV of heating waters versus the solar collectors. One of the detriments with the solar collector is how and where it's installed, and there is plumbing. There's quite a bit of plumbing that has to go from the collectors on the roof into wherever you have your thermal store, your hot water tank. Seen some installations where the thermal collectors are in a garage, and then the tank is in the house, and it may be not that far, 20, 30 meters, but there's a degradation of the temperature coming from the solar collector, and it's really inefficient. Also, there is maintenance with this. Typically with solar panels, you plug it in and you shouldn't have any problems. It's just electrical. It's a lot less maintenance and really more effective. So hopefully that answers the questions. Okay, Brendan, what percentage of the nominal power do you get from a normal roof-based system facing south in A, winter, and B, in summer? I've seen others with this that seem to be about 20% in winter and 80 to 90% in summer. Is that typical? It kind of depends. You know, as well, Chris asked earlier about tracking the sun. If you want to make maximum power, you need to be pointing at the sun at all times. So obviously, you know, facing south is where the sun is going to be at its highest point during the day, solar noon. Anything beyond that, during the morning time, it's rising to that high point, which means there's lesser radiance. I think everybody knows that the sun isn't as bright at sunrise and sunset as it is at midday, right? So the higher it becomes, the more irradiance and the more you can capture. So this is why we always, you know, face them south. And as far as in winter, it depends on the angle. It depends on your geographic location. The further you get to the poles, the lower the sun is going to be in the sky. And the lower it gets, the harder it gets. I found, you know, we get to below 15 degrees here in late December. So once you get below 20 degrees for the highest point, it does become quite challenging to generate power. And you can see once you start getting up to 20 degrees, that the rays can come down through less atmosphere, and how much easier it is to generate power. So it depends on the angle of your roof, as I mentioned earlier. You have to look at where is the sun going to be, depending on your geographic location. What's the angle of my roof? And then in wintertime, what is that difference? You know, I know a system in Switzerland. I used to live in Switzerland a few years ago. That it's very shallow roof. It's pointing up at the summer sky, and it is oriented at where sun sets in late December. Unfortunately, that system is going to have a very poor angle to the sun, even at midday, and it's going to have a very, very poor generation capabilities. You know, it depends on sometimes how you use power. Are you using power later in the day? Some people want to orient their panels really more westerly because that's when I use most power, but the sun has to be out at that time. As an installation off-grid system I'm working with, he has a friend that's adamant that he should face his panels angled to the west and angled to the east, because you'll capture more power longer. But that's not true in winter, because where I live, the sun rises at 130 and sets at 230. It's a very narrow angle. And if you did that type of installation rather than face them south, you will not be able to generate at that time of year. It'll be about 10%, rough calculations I did, you'll generate about 10% less. And that's significant if you want to be off grid. Hopefully that answers the question. Let's see. Oh, there's a lot of questions in here. For Alex, for the case study, as you mentioned, what are installation costs for the different stages of installation, and how long will the system take to pay for itself? Well, you know, that was a Victron kind of installation. That's what has been planned. And if you buy from certain distributors, it can cost quite a bit more. So if you do your legwork, you can significantly reduce the cost. So over the numbers off the top of my head, I think the initial investment was probably so this is for a 6.4 kilowatts of PV, a 5 kVA inverter, 5 to 7 kilowatts of battery, and the charge controller. I believe it was somewhere in the order of around 12 to 13,000 if you sourced them through some people I know. our distributors of Victron equipment, and if you buy the bulk of things from them, they'll give you a heavily much reduced cost. So I think, yeah, the initial investment to get going was in the region of 12 to 13,000. There is a grant available in Ireland, which I think at the time was, maybe now is around 3,000. So we reduced their costs down to around 10,000 for the initial investment. The subsequent installations also probably in the 1 to 2,000 for the PV and the charge controller. If you factor in the costs of cabling, and the one on the shed's going to have a trench dug up to the house. Additionally, each chart, I think each inverter cost is in the region of around 2 to 3,000, depending on the model. There's a couple of different models they could go with. So how long would that take to pay back? If you're looking at raw numbers, I mean, what is the price of electricity going to be next year? Could anybody have imagined the costs? I know here in Ireland, I know many of my neighbors, oh, look at my price of my bill. It's tripled in the last 2 years. You don't know what the cost of electricity is going to be. And as I always say, when people ask me about our situation being off-grid, is what is the cost, or what is the value associated with you having power when everybody else has gone out? It's hard to say. We have an electric car as well, and it's 100% solar powered. The return on that has been more than I thought. If I've calculated my investment and maybe my return using raw numbers of what everybody's paying, how I heat my home, I would say my system in 1 and probably 2/3 of a year has already paid for itself, 1/4. So quite quicker than I thought. But there has been times where power's been out up here, and I get pinged. You've got power, right? And then we look outside and it's pitch black. So there's a value with that. Okay, probably answering one other question here. Dennis Bates. I have 14 PV panels and a Pylon-Tech battery, 4 kilowatt hours. The battery hovers around 20% charge and rarely fluctuates. The Solus app tells me that my house consumption is always above panel output regardless of solar conditions or household usage. I have tested this on strong sun days by turning off all discretionary appliances. Still, the battery sits at 20%. Without knowing a few more details here, it would be hard to say. If you have a Solus inverter, is it charging the battery? If you've turned everything off and the inverter, even with good PV power, is not charging and it's only sitting at 20% state of charge, it could be either something wrong with the battery or it really isn't charging the battery. So maybe here, if your consumption is always above panel output, regardless of solar conditions, that doesn't sound right. You have to look at the telemetry. It would be hard to look at this. I mean, if you could shut your consumption off, if you can, on a day where you've got some sun, and see if the battery is charging, you should have some information on the telemetry to see what the charging rate is. Without looking at any data, I couldn't really say. It could be quite a few things. Let's see. Okay, I'm just going to answer one more question. There's so many in here, I probably didn't get to many. Anonymous attendee, will electric companies force removal of rotating disk electric meters in the near future? Mine rotates backwards when the sun is up. I think there's a big, I actually worked on this technology. Smart meters, basically is what I'm talking about. Everything's kind of being replaced everywhere. We did, because I'm very rural, did have a rotating meter up until about 2 years ago, and they replaced it anyway, even though I'm off grid. It still sits in our little outbuilding. The infrastructure is still there, but I think that's all being replaced now. It depends on the country and the state of what is what state of the infrastructure. But here everything's being replaced. I couldn't tell you where a rotating meter is. So that is coming. And they can get all this information from these type of meters. I actually worked on that technology. Okay, I think I've overused my time here. Unfortunately, I can't answer all the questions, so I'm going to pass it back to Ching now.
Thank you, Ken. Thank you for an excellent presentation, and thank you for answering lots of Q&A. You've covered the topic very well and very in detail. In light of the recent high energy costs, you have given us an insight and assist those who are considering moving to a more sustainable way of living. And on behalf of the IET network, I'd like to thank Ken again for his presentation and sharing his knowledge with us. I'd also like to thank the audience for attending this evening webinar. And now we'll pass it back to Chris to close the webinar. Chris?
Thanks again, Ken, for an excellent presentation. So goodbye for now.